Okay, so here it is. So these are all the concepts. Now it's a very easy and a very small topic. Now it may seem that there are a lot of concepts, okay, but most of them are pretty easy and not going to take us very long. So hopefully we will finish this today only with past paper questions. Okay, so let's write down the date. It's the 23rd. Okay, so altogether there are 8 concepts. Okay, number one is order of a matrix, where we write down, we look at a matrix and we decide what is the order. Okay, looking at the number of rows and the number of columns. Number two is addition and subtraction of matrices. Okay, then there are two types of multiplication. One is scalar multiplication and the other is matrix multiplication. Scalar multiplication, very easy. Matrix multiplication is a bit tricky, but with practice, hopefully you guys will get the hang of it. Then there is something called identity matrix. Okay, we'll learn about this as well. Then we'll learn how to find out the inverse of a 2 by 2 matrix. Okay, I should mention that over here, that it's only the inverse of a 2 by 2 matrix that's in our syllabus. And then there is something called finding x through matrix multiplication. Again, very easy concept, just two scenarios that we have to remember. And then there is word problems, which can cover any of the concepts mentioned above. Okay, so we'll start with order of a matrix. So any matrix is defined by its number of rows and its number of columns. Okay, so if let's say I have a matrix over here, let's call it matrix A. Okay, and this is what it looks like, 3 1. Okay, and we need to write down the order of this matrix. So remember this, that any order of a matrix is basically defined by the number of rows, okay, times the number of columns. Okay, and that doesn't mean that we actually multiply the two and give the final answer as one value. We don't. Like, for example, if let's say you're supposed to give the measurement of a room, or let's say of a carpet. So if let's say it's 6 feet by 4 feet, so you say 6 by 4 only, okay? Because you don't. The reason why you don't multiply it, give the final answer, is because if let's say it's 6 by 4, which is 24, so it could be 24 by 1, that's also 24. It could be 3 by 8, that's also 24. Okay, 4 by 6, 6 by 4, 12 by 2. Okay, so that's why we leave the number of rows as it is and we leave the number of columns as it is. Okay, we don't actually multiply the two. So what are rows? Rows are basically what the horizontal values are, your rows. Okay, and the vertical, what what you have over here, okay, these vertical values are your columns. Okay, so for example, if you look at this matrix, how many number of rows do we have here and how many number of columns? We have 2 rows and 1 column, so we say that this is a 2 by 1 matrix. Okay, or we also call this a column matrix. Why do we call it a column matrix? It's because it has only one column, so that's why we call it a column matrix. Let's say you have something that looks like this: B, which is equal to 3, 2, 5, 7, 1, minus 4. Okay, just random values. So let's say we want to write down the order of this matrix. So we'll count the number of rows. So here's row 1. Okay, here's row 2. So that's 2 rows. And then we'll count the number of columns. So column 1, column 2, column 3. So how many columns do we have? We have 3 columns. So that means the order of this matrix is 2 by 3. Or you can say that this is a 2 by 3 matrix. Okay. What do you think about this? What's the order of this matrix?
1 by 1.
Yep, it's just a 1 by 1 matrix. Okay. All right. Let's say that we have something like this: 3 minus 1, 4, 8. What's the order of this matrix?
2 by 2.
It's a 2 by 2 matrix. Okay, because you have 2 rows and 2 columns. Okay, so that's how you write down the order of a matrix. Okay, so long story short, the order of a matrix is defined by its number of rows multiplied by its number of columns. Do we always write rows first? Yes, we always give the rows first. Okay, because this is the standard that has been set. Okay, so a 2 by 3 matrix for me has to be the same 2 by 3 matrix for you. Okay, we have to be on the same page to make sure that we're talking about the same order. So that's why the standard has been set, and that is that you give the rows first and then you give the columns. Okay, all right. Then comes addition and subtraction. So in order to add two matrices, there's just one rule that we have to follow. Okay, or subtract, not just add or subtract. So I'll write that down. two matrices can only be added if and only if, okay, if and only if the order is the same, okay. And it's not just two, okay. Two or more matrices can only be added, and again, not just added but also subtracted if and only if the order is the same, okay. So for addition and subtraction, there's just one same rule, and that is the order has to be the same. So let's look at a few examples. Let's say you're given a is equal to 3, 5, 1, 8, okay, and you're given b as, let's say, 1 and 9, and you're given c as, let's say, 3 minus 2 minus 7 and 0, okay. So let's say if I do a plus b, is that possible? Can you add these two matrices together? Nope. So a plus b is not possible. Why? Because they have different orders. Alright, what about a plus c? Is that possible? What do you think? Yep, it is possible because they have the same order. Okay, now how do we do a plus c? So 3, 5, 1, 8, okay, plus 3 minus 2 minus 7 and 0. So you add the corresponding elements, okay. So this 3 basically belongs to the first row and the first column, okay. So this 3 will be added to this 3 because this also belongs to the first row and the first column. So if you want, initially, I would suggest that you spread out your working and don't do it directly. Later on, if you want to do it directly, that's fine, okay. But here's how I'm going to do it first. So this 3 plus 3, okay, and then 5 and minus 2 will be added because they're the corresponding elements, okay. And then 1 and minus 7 will be added, so 1 plus minus 7, and then 8 and 0 will be added, so 8 plus 0. Alright, so let's simplify this. Let's see what do we get. So we get 3 plus 3, which is equal to 6. 5 plus minus 2 is positive 3. 1 plus minus 7 is minus 6. 8 plus 0 is 8. And there you go. This is how you can add or subtract two matrices. Okay, great. So here's what we're going to do. We're not going to do many examples in between, okay. We'll do few examples in between. We will do examples for complicated concepts such as matrix multiplication and inverse, okay. The idea is so that we can get to past paper questions as soon as possible and then do as many of those as possible, okay. So but still, if you guys still have any questions, feel free to ask. There you go. All right, so concept number 3, again very easy, scalar multiplication. So scalar multiplication generally looks like this. So if, let's say, you have a matrix which is a, b, c, d, and let's say you have a constant which you're multiplying with this matrix, okay. So what is that gonna do? That means every element of the matrix will be multiplied by the constant that you have outside, okay. So this is what scalar multiplication basically is, and it doesn't necessarily have to be a 2 by 2 matrix. It could be a 2 by 1 matrix, 1 by 2, 1 by 1, okay. It could be anything. So for example, let's say you have a which is equal to 5 and minus 3, okay, and you're asked to find 2a, okay. So what does that mean? 2a basically means that you take 2 and multiply 5 and minus 3 with it, okay. Now this is not a fraction, okay. So this 2 will be multiplied by the first element, okay, 5, as well as the second element, which is minus 3, okay. Do not treat it as a fraction so that you only end up multiplying 5 and 2 together. You have to multiply 5 by 2, which gives you 10, and also 2 by minus 3, which gives you negative 6, okay. So this is what scalar multiplication looks like. Now scalar multiplication, so this is the question, find 2a, okay. That's what the question says, okay. It will be given to you in the question, so don't worry. Let's say you have 3 minus 1, 4, 2, and you're asked to find 3b, okay. So what are you going to do? It's pretty easy. You're going to take 3 and you're going to multiply all the elements of matrix B by 3, okay. If you do that, 3 times 3 is 9, 3 times minus 1 is minus 3, 3 times 4 is 12, 3 times 2 is 6, okay. Now let me tell you one thing about matrices. irrespective of the concept, whether it's addition, subtraction, multiplication, inverse, identity, anything, 95% of the reason why students lose marks is because of careless errors. Okay, like think of all the things that can go wrong over here. Like for example, it's possible that you may end up forgetting multiplying one element by 3. Okay, and the thing about matrices is that it's very unforgiving in the sense that you will have a 1 mark question only. Okay, so this would be a 1 mark question. So that means अगर आपने एक sign भी आगे पीछे कर दिया ना, so you don't get a mark. You either get a mark or you don't get a mark. That's the thing about 1 mark questions. So in order to get that 1 mark, it has to be exactly correct. You can't afford even the smallest of sign error. Okay. Normally in other questions, like let's say mensuration, if you end up making an error, if you've done everything else correctly, you will still get some marks, right? Because it's not a 1 mark question. It's a 3-4 mark question. But with mensuration, with matrices, you have to make sure that you don't make any error at all. Okay, let's do another question. Let's say that we have a which is equal to 3 minus 2. Okay, b which is equal to 5 and minus 8. Alright, and c which is equal to 0 and 7. Okay, now all of this is given to you in the question. And let's say there are parts to this question. There's the first part where you have to find out 2a, pretty easy. There's part b where you have to find out a minus 2b. Okay, so we'll figure that out. And then there's part c where you have to do 2a plus 3b minus 3c. Okay, so this is how the question can get more and more lengthy, not complicated, okay, because the concept is the same, but this is how the question can be basically lengthier than usual. So 2a is pretty easy, it's a no-brainer. All you have to do is take 2 and multiply the elements of a by 2. So what happens when you do that? 2 times 3 is 6, 2 times minus 2 is minus 4. And that's it. That's the answer to part A. In part B, where you have to do a minus 2b, so in this case, be extremely careful. You're not multiplying minus 2 by b. Okay, you're multiplying b by 2 only, and then whatever the result turns out to be, you will then subtract it. Okay, if you end up multiplying b by minus 2, then you won't have to subtract the two matrices anymore. You'll have to add the two matrices anymore. Okay, you'll have to add the two matrices then, which is why I would suggest that you leave the minus sign as it is, and then you multiply 2 with the two elements. So 2 times 5 is 10, 2 times minus 8 is minus 16. Okay, minus apni jagah pe intact hai, there's nothing happened to the minus sign. Okay, and now you subtract the 2. So 3 minus 10 is minus 7. Minus 2 minus minus 16 will become, be careful of the signs, like I said earlier, will become minus 2 plus 16, which is equal to positive 14. And please do not make the mistake of thinking of this as a fraction and end up simplifying it and writing it as minus 1 upon 2. Okay, don't do that. This is not a fraction. Minus 7 and 14, they're independent of each other. Okay. So, any questions? So basically 2a, we already know what 2a is. That's 6 and minus 4 plus 3b. So if you guys want to do that directly, you can. Just be careful. Don't end up making a calculation error. 3 times 5 is 15. 3 times minus 8 is minus 24. Okay, minus 3 into c. So 3 into 0 is 0. And 3 into 7 is 21. Okay, so let's see what do we get. 6 plus 15 is 21. Okay, minus 4 plus minus 24 is minus 28. Minus 28 minus 21 is minus 49. So 21 and minus 49 is the correct answer. Okay, so I hope everyone's gotten the correct answer. If not, you can see what you've done wrong. आप बताएं कहाँ से आया, गौर से देखें और सोचें कहाँ से आया.
ये आपने 6 को 15 से किया?
नहीं, सोचें 3c है ना. What's c? C is 0.7. So what happens if you multiply 0.7 by 3?
Okay.
Alright, sounds good. Okay, so what we have done so far is a piece of cake. Okay, matrix multiplication is a bit tricky. Okay, let me tell you that. And let me tell you one thing as well, that after one example, I don't expect all of you to fully comprehend how it's done. Okay, unless you know it from before and you know it very well, I'm sure you will get it. But for those of you who are doing it for the first time, let me do a few examples, okay, before you ask your questions. All right. But first, let's write down the rule for two matrices to be multiplied. Okay. So the rule is two matrices can only be multiplied if the number of columns in the first matrix, number of columns of the first matrix, Carlo, is equal to, or equal to, doesn't matter, the number of rows of the second matrix. Okay. Now, what does that mean? So let's say you have a matrix over here, which is 3, 5, minus 2, and 1. Okay. And let's say you have B, which is 1 and minus 3. Okay. Now let's say I want to multiply these two matrices. And make a note of one thing. Remember one thing. In matrix multiplication, AB is not the same as BA. Okay, normally in regular numbers, let's say we do 3 into 5, that's 15. We do 5 into 3, that's also 15. Okay, but in matrices, it's not the same thing. A being multiplied by B, you will notice, is not the same as B being multiplied by A. Okay, so let's say you have to find out AB. What does that mean? That means you have to multiply matrix A with matrix B. Okay, so the first thing you need to do is you need to decide whether that's even possible or not. Okay, how do we decide that? Let's rewrite the two matrices. Okay, in fact, let's not rewrite them. That'll be a waste of time. Let's just write down the order of matrix A. So that's 2 by 2. Okay, let's write down the order of matrix B. That's 2 by 1. Now let's read the statement that we have written. Two matrices can only be multiplied if the number of columns of the first matrix, which by the way is 2, is equal to the number of rows of the second matrix, which is 2 as well. So are these the same? Yes, they are. So that means the multiplication is possible. And there's something else that you can also determine, and that is the order of the final matrix. Okay, what does that mean? That means after you've multiplied, what does the final matrix look like? What should the final matrix look like, as in how many rows and how many columns? That is something that you can determine as well. And what is that? That is basically equal to the number of rows of the first matrix times the number of columns of the second matrix. So this 2 by 1 will basically be what? Will basically be the order of the product. Okay, order of the product means that order of the matrix that you get after you've multiplied the two. Okay, now let's actually multiply the two and see what we get. So if I want to multiply the two, here's what I'm going to do. 3, 5, minus 2 and 1, okay, is being multiplied with 1 and minus 3. Okay, you don't multiply or let's multiply them. Now the question is, how do we multiply them? Okay, when we're adding them, things are pretty straightforward. Okay, you take the corresponding elements and you add them. Okay, now here they don't even have the same order. I can't say that 3 will get multiplied by 1, then what's going to happen to this 5? Okay, so what do we do? So what we do is the following. We multiply the first row by the first column. Okay, now since we don't have more than one column over here, so remember, in the case of multiplication, we follow this rule where we say rows into columns. Okay, or you can sort of think of it this way, that the multiplication is done in this order. Okay, where you take the number of rows, or you take the row of the first matrix and multiply it by the column of the other matrix. Now how does that work? Let me show you. Now if I ask you, how many elements do we have in the first row of this matrix? How many elements do we have in the first row of this matrix? 2. Very good. How many elements do we have in the first column of this matrix? 2. Okay, so notice how the number is the same. that is the reason why they can be multiplied. So what that means is that the first element of the first row, which is 3, will then be multiplied by the first element of the first column of the other matrix. That means 3 into 1. Okay, so 3 gets multiplied by 1, 5 gets multiplied by minus 3. But the thing is, what do we do with these results? We add them. So 3 into 1 plus 5 into minus 3. So notice how the first column has now, first row has been multiplied by the first column. Okay, and where did we write a result? We wrote a result in the first row. So if you're multiplying the first row with the first column, that's where we will write a result as well, in the first row and the first column. Okay, now since this row is multiplied, yes, there is some multiplication and simplification to be done. We'll do that later. But now it's time for the second row to be multiplied by the first column. So now we take this second row and we multiply it by the first column, okay, of the second matrix. So notice here also we have two elements horizontally. Here also we have two elements vertically. So minus 2 gets multiplied by 1. Minus 2 times 1 plus 1 times minus 3. 1 times minus 3. Now you can't leave it over here, of course. You have to simplify it. Any answer that you give in matrices, you have to simplify it. So 3 into 1 is 3. Now you can do it in step by step, or if you want to do it directly, that's up to you. Since this is the first question, I would do it step by step, and then later on I would do it directly to save some time. So 3 minus 15, minus 2 minus 3, and what's 3 minus 15? 3 minus 15 is negative 12, minus 2 minus 3 is minus 5. And notice what we saw earlier. We saw that the final answer has to be a 2 by 1 matrix, which it is. So that means we've done everything correctly. And this is how you multiply two matrices together. Now, I don't expect you to fully comprehend what I've done, okay? It's tricky, it's confusing, I know, don't worry about it, but we'll do more examples. This is the one concept of which we will be doing the most examples, so don't worry, all right? I'll leave this on the screen for a minute in case you guys are copying or whatever, okay? And then I'll do some more examples and more complex examples as well. Okay, now look at this and tell me if I can multiply these two matrices. How did we find out the order of the matrix before solving it out? Okay, so remember, once you write down the order of the two matrices that you're about to multiply, you do that for two reasons. One is to determine if the multiplication is possible or not, and the other is to determine the order of the final matrix. So how do you determine the order of the final matrix? It's equal to the number of rows of the first matrix into the number of columns of the second matrix. Okay, so I hope that helps. All right, what do you think about these two matrices? Can we multiply these two? Let's see. The order of the first matrix is 2 by 1. The order of the second matrix is also 2 by 1. So can we multiply these two?
No.
No, we can't. Okay, so what we say is not possible. Okay, so just because two matrices have the same order does not mean that you can multiply them. Yes, you can always add or subtract them, but as far as multiplication is concerned, no, you can't multiply two matrices just because they have the same order. Now, if they were, let's say, a square matrix, what do we mean by a square matrix? Square matrix basically means like a 2 by 2, 3 by 3, 4 by 4, 1 by 1. In that case, yes, it's possible. But if it's not a square matrix, if it is a matrix with different number of rows and different number of columns, just because they're the same doesn't mean that you can multiply them. Okay. Now let's do an example where we can actually multiply the two matrices, so we further get the hang of multiplying matrices. So let's say that you're given 3 minus 2, 1, 5, which is being multiplied by 0, 1, 3, 2. Okay, just some random values, all right? Now, can these two matrices be multiplied? Let's answer the first question. Yes or no? Yes, they can. Very good. Why? Because the number of columns of the first matrix is equal to the number of rows of the second. Okay, so yes, it is possible. So since they're equal, that means it is possible. Just a second. Yeah. Now the question is, what can we expect the final order to be, or the order of the final matrix to be? That also has to be a 2 by 2 matrix. Okay. Now let's actually multiply the two and see what happens. Now when you're multiplying the two matrices, here's what you have to do. Now hold on to this row, okay, and multiply it with both the columns one by one. Okay, or in other words, hold on to this row for as long as you haven't multiplied it with all the columns that you have. Okay, so we fix the row and we multiply it with different columns. So we fix this row. First, we're going to multiply it with this column. Okay, and then we're going to multiply it with this column over here. All right, now I'll write down the values that I'm multiplying. So 3 gets multiplied by 0. So 3 times 0 plus minus 2 gets multiplied by 3. Why? Because minus 2 is the second element of the first row, 3 is the second element of the first column. Okay, so minus 2 times 3. Let's write that down. All right, and then you can make a bracket around these values if you want. Now, the first row so far has been multiplied by the first column. So you can see that I've written the result in the first row and the first column. Now it's time to keep holding on to the same row and multiply it with the second column. So where am I going to write my result now? I'm going to write the result in the second column. What does that mean? That means I'm going to write the result over here. So 3, which is the first element of the first row, gets multiplied by 1, which is the first element of the second column of the other matrix. So 3 into 1 plus minus 2 into 2. So minus 2 into 2. There you go. Now that we have multiplied the first row with both these columns, what do we do now? We multiply the second row. Okay, so now it's time for 1 and 5 to be multiplied by both these columns. So 1 times 0, 1 times 0 plus 5 into 3. Okay, and now it's time for this row to be multiplied by this column, which means 1 into 1. Okay, plus 5 into 2. And now you can write down your final answer. So here I'll skip a step in the sense that I'll just simplify both the numbers, add them, and then write the final answer. So 3 into 0 is 0, minus 2 into 3 is minus 6, 0 minus 6 is minus 6, okay. 3 into 1 is 3, minus 2 into 2 is minus 4, so 3 plus minus 4 becomes 3 minus 4, which is going to be minus 1. 1 into 0 is 0, 5 into 3 is 15, so that's pretty easy, 15 it is. 1 into 1 is 1, 5 into 2 is 10, 1 plus 10 is 11. So there you go. This is your final answer. Now take a good look at what I've done. Let me know if you have any questions. Let's say that you have the following. Now let's do a really complex example, in fact. Let's say you have 4, 3, 2, 1, which is now being multiplied by a 2 by 3 matrix. So let's say 1, 0, 5, minus 2, 3, negative 4. Okay. So first question, is it possible to multiply these two matrices? Okay. Yes, it is possible. Okay. And can you also tell me the order of the final matrix? Considering
2 into 3.
Yep. 2 by 3. That's correct. Okay. Now let's actually start multiplying these two. Okay. Which will require a lot of patience. So first we hold on to this row for as long as we haven't multiplied this row with all the columns that we have. Okay. Acha. Ab I'll skip a few steps. Okay. So if at any point you don't know what I've done, feel free to ask. So 4 into 1 is 4. So instead of writing 4 into 1, I'll just write 4 directly. Okay. And then 3 gets multiplied by 0, which is 0. So I'll just write 0 directly. Okay. 4 into 5 is 20. So now since we are multiplying the same row with the column next to it, so we start writing our answer with the in the column next to it as well. So 4 into 5 is 20. 3 into minus 2 is plus minus 6. So we'll simplify this in the next step. 4 into 3 is 12 plus 3 into minus 4 is minus 12. Okay, so we'll simplify this in the next step. Now that the first row has been multiplied, what do we do now? We move on to the next row. Okay, so 2 into 1 is 2. All right, 1 into 0 is 0. Okay, 2 into 5 is 10. Then 1 into minus 2 is plus minus 2. Okay, 2 into 3 is 6 plus 1 into minus 4 is minus 4. And now we simplify, so we have 4. 20 minus 16 is 14, 20 plus minus 12 is 0, 2 plus 0 is 2, 10 minus 2 is positive 8. I was about to write negative 8. That could have cost me the 1 mark this question could have been out of. 6 plus minus 4 is 6 minus 4, which is equal to 2. And there you go. This is your final answer. So, as always, take a good look at what I've done. Let me know if you have any questions. Take your time, since this is the first time that you guys are doing it. If it is the first time, okay. I'm sure school mein to kiya hoga. But in any case, take your time. No need to rush into it. It's important to get the right answer.
22, 17, 18, and 7.
22, 17,
18 and 7.
18 and 7. Okay. I don't know if this is the correct answer. Let me just quickly check if it is. Yep, it is. 22, 17, 18, 7. That is the correct answer. Good job. Okay, I hope everyone else is also getting the same answer. In case you're not, okay, I would suggest you try and see what you've done wrong yourself. 9 out of 10 times it's likely that you made a sign error or a calculation error. Okay, or koi possibility nahi hai. Okay, now, so let's see how many concepts we've done so far. Okay. So we've learned how to find out the order of a matrix, we've learned addition and subtraction, we've learned scalar multiplication, we've learned matrix multiplication. Now let's see what the identity matrix is. Okay. It's 1, 0, 0, 1. Okay.
Oh.
This is what the identity matrix is. Okay. And think of identity matrix as the one of matrix. One of matrices. Okay. What by one I mean like the number one of matrices. You know what's so special about number one is that if you multiply 5 by 1, what happens to it? It remains 5. If you multiply 10 by 1, what happens to it? It remains 10. If you multiply minus 3 by 1, what happens to minus 3? Nothing. It just remains minus 3. Okay. So that's what I want you to think of identity matrix as. Why? Take any 2 by 2 matrix. Okay. Let's say we take let's just write down a random 2 by 2 matrix. Okay. Let's call it A. So let's do it over here. So let's say you have A, which is 3 minus 2, 2, 1. Okay. So let's say you're asked to find AI. Okay, which means you take A and multiply it by I. So how do you do that? 3 minus 2, 2 and 1. Okay, and then you multiply it by 1, 0, 0, 1. Now the first question is, can we multiply the two matrices? Yes, we can. The second question is, what is the order going to be? It's going to be a 2 by 2 matrix. Okay, and now we finally start multiplying the two matrices. Okay, so if I multiply the first row with the first column, 3 into 1 is 3, plus minus 2 into 0 is 0. And then if I multiply the first row with the second column, so 3 into 0 is 0, plus minus 2 into 1 is minus 2. And now we multiply the second row, 2 into 1 is 2, plus 1 into 0 is 0, 2 into 0 is 0, plus 1 into 1 is 1. Now, did you notice something? When I simplify this, notice what I get. 3 minus 2, 2 and 1. Now try and make an observation over here. Tell me, what do you observe? Sorry? It's the same. Okay, now let's say that it's a coincidence. Okay, let's assume it's a coincidence. Okay, so let's say that we have 3 minus 2, okay, which is just another random matrix, and now we're multiplying it with the identity matrix, which is 1, 0, 0, 1. Okay, let's see what happens. So first of all, can these two matrices be multiplied? Achha, in fact, wait a minute, they can't be multiplied. But what if I change the order and then write it? Tab multiply ho jayenge. Yeah, let's write it like this. Okay, now these two matrices can be multiplied. Okay, now let's multiply and see what we get. So 1, 0 will be multiplied by 3 and 2. 1 into 3 is 3, 0 into minus 2 is 0. Okay, 0 into 1, 0 into 3 is 3, and 1 into minus 2 is minus 2. So again, did you observe something? Did you notice something odd? What do we get?
Yes.
We get the same thing. Okay, so remember this note here. Note: any matrix multiplied by the identity matrix will remain unchanged. Any matrix multiplied by the identity matrix will remain unchanged. What does that mean? That means if you do A times I, the answer will be I. Or let's say if you do I times B, the answer will be B. Okay, So that's what identity matrix is. It's a matrix which, if you multiply any other matrix with it, the answer remains the same. Okay, so there will be some questions where the question will ask you to find out A into I. Okay, so for that, you don't need to do any working, you just need to write down matrix A, whatever that may be. Okay, when we get to past papers, you'll understand how it works. Okay, so we're done with that's pretty much it as far as identity matrix is concerned. Okay, but let's see what the inverse of a matrix is. So this is also another complex concept. Okay, but not as complex as multiplication. If you found multiplication easy, then this is going to be a piece of cake. So how do we find the inverse of a matrix? So remember, we only have to learn how to find the inverse of a 2 by 2 matrix because that's the only thing that's in our syllabus. So if, let's say, you have a matrix A, which is A, B, C, D. So there's this one formula that you have to remember, which is 1 upon AD minus BC. Okay, this is how you find A inverse. And then you multiply this with D, A minus B minus C. Now there are some terms that we use to basically define what this is. Like for example, this is called the adjoint matrix. You don't need to memorize that. Okay, this is something that you need to know. This AD minus BC that you're looking at is basically what we call the determinant of matrix A. Okay, so if, let's say, you're only asked to find out the determinant of any 2 by 2 matrix, all you have to do is AD minus B into C. Okay, now this is just the formula. Let's do a few examples so that you guys further get the hang of it. So let's say you have 3, 1, minus 4 and 5, and your job is to find the inverse of this matrix. Okay, that's what inverse is, right? You write to the power minus 1, like sine inverse, cos inverse. Okay, so how do you do that? How do you find the inverse of this matrix? Here's how you do it. 1 upon 3 into 5, which is 15, minus 1 into minus 4, so that's minus 4. Later on, minus minus will become plus. And then what you do is A and D swap places. So in place of 3, we have 5. In place of 5, we will now have 3. 1 and minus 4 will change signs. So the sign of 1 will now be minus 1. The sign of minus 4 will now be 4. Okay. And now what you have is this 1 upon 19 into 5 minus 1, 4, 3. Now you can leave it as like this, or you can write it like this as well. 5 upon 19 equals to minus 1 upon 19. Sorry, not equals to. 5 upon 19 minus 1 upon 19, 4 upon 19, 3 upon 19. Now, if you write it like this, then you have to check whether any element can be simplified further. If it can be simplified further, then you have to simplify it. If it can't, then you leave it as it is. Okay? So this is how you find out the inverse of a matrix. Just remember this formula. Okay? It's very important. If you memorize the formula, that's good enough. Okay, let's do another example, and then I'll take your questions if you have any. So let's say you have matrix B, which looks like this. 5 minus 1, 3, and let's say 2. Okay, and you have to find B inverse. Okay, so 1 upon 5 into 2 is 10. Okay, minus 1 into 3 is minus 3. So we'll simplify this in the next step. Now 5 and 2 will swap places, so in place of 5 we'll have 2, in place of 2 we'll have 5. The sign of minus 1 and 3 will be changed, so we'll have 1 here and minus 3 over here. Okay, so our final answer becomes 1 upon 13 into 2, 1, minus 3 and 5. And I will strongly recommend that you leave it like this only. Don't multiply 1 upon 13 with all the other elements, because then it gets complicated. Okay, especially if you have to simplify it further. So make sure to read the question carefully. If the question has asked you to give the answer a certain way, then you have to give it that way only. But if it hasn't, then this is good enough. Okay, now take a good look at what I've done. Let me know if you have any questions. I'm about to give you guys a few inverse questions to solve. चलें ये क्वेश्चन करें. Let me know when you have the answer. All right, let's have the answer.
I simplified it further, so it's 2 minus 3 upon 2, 3 and 5 upon 2.
2 minus 3 upon 2, 3 and 5 upon 2.
5 upon.
ठीक है. Let's say if you didn't simplify, then your answer would be 1 upon 2, 4 and 5, minus 3, minus 6. There you go.
So my answer is the same, but it's minus 3 instead of just 3. Is that correct?
Oh yeah, it will be minus 3. Okay. It has to be minus 3. So yeah, your answer is correct. Okay, so that's it as far as inverse is concerned. Okay, now this is something that I'm going to put on hold for now. Okay, let's do some word problems and let's do some full length past paper questions. Okay, because this is not something that's tested. Okay, and it's part of you'll find it in a few books actually, but you won't find it anywhere in past papers. We will do it. Okay, obviously it's officially it is part of the syllabus, but let's do word problems for now, and that way we will be able to solve some full length questions as well. All right, so here's a question. This is from May June 2014, paper 1, like I said. Okay, let's see what it says. So it says here, a cafe sells hot drinks. Okay, on Monday, it sells 80 teas, 60 coffees, and 40 hot chocolates. On Tuesday, it sells so many teas, so many coffees, and so many hot chocolates. Okay, a cup of tea costs 0.8 cents. $0.8. A cup of coffee costs $1, and a cup of hot chocolate costs this many dollars. Okay, this information can be represented by the matrices M and N below. Okay, so here you have the same information. Okay, represented in a matrix. Work out Mn. So that's pretty easy. We just have to multiply these two matrices. Okay, so 80, 60, 40, 70, 90, and 50. So can these two matrices be multiplied?
Yes, sir.
Yes, they can. If the question is asking you to do it, that means of course it's possible. Okay, now bear in mind that this is a paper 1 question. Okay, and when you do multiply the two matrices, so you have one row being multiplied by one column, and then you have another row being multiplied by the same column. So your answer is going to be a matrix which has 2 rows and 1 column. Okay, so basically let's write it down. 2 by 3 is the order of the first matrix, 3 by 1 is the order of the second matrix. So yes, we can see that it is possible, and once you have multiplied, we're expecting something like this, 2 by 1. Okay, now this is a paper 1 question and it requires a decent amount of multiplication, so just be careful. Okay, 80 into 0.8 is going to be 64. 60 into 1 is going to be 60. 40 into 1.2 is going to be what? 48. 12 into 4, 24. Yeah, 48. Okay, great. 70 into 0.8 is going to be 56. 8 sevens are 56. Yeah, 90 into 1 is 90. Okay, and 50 into 1.2 will be 60. Okay, so now let's simplify this and see what do we get. So 64 plus 60 is going to be 124. 124 plus 40 is going to be 164. 164 plus 8 is going to be 176. Okay, so I'm just going to check my answer to make sure that I'm doing it correctly. 64 plus 60 plus 48, 172 actually, sorry, not 176. Okay, and then 90 plus 60 is 150. 150 plus 56 is going to be 206. Okay, let me just double check. 6 plus 90 plus 60, yep, 206. So there you go. This is the answer to the first part. Okay, and that's how normally a word problem question is going to be like. Okay, and then comes part B, which says explain what the numbers in your answer represent. Okay, so let me ask you guys, 80, 60, and 40 were the number of hot chocolate, or were the number of tea, coffees, and hot chocolate sold on Monday, respectively. Okay, and these are the numbers sold on Tuesday. Okay, and we're multiplying them by the amount that they cost. Okay, and this is what we end up with. So, what do you think these numbers are representing?
So the
So these are representing the total income.
Yes. So 172 and 206 basically represent the total revenue or income on Monday and Tuesday. Okay, so you don't have to just brainlessly multiply the two matrices. You have to keep your eyes and ears open and see what it is that you're multiplying. 80, notice how is being multiplied by 0.8. So 80 is the number of teas sold, 0.8 is the amount that it costs. So we have the amount of income that we got through yes, Alishwa, your answer is correct. So we ended up with the amount of money earned through teas on Monday. And just like that, this 60 tells us the amount of money earned through coffee on Monday and then hot chocolate. Okay, and then the same for Tuesday. Okay, so total revenue on Monday and Tuesday. Acha, now while I was going through these past papers, I realized that there is one concept that we should cover. Okay, and it's part of the identity matrix only. Okay, so here is where's the identity matrix? Here it is. Yeah, okay. So basically, notice how we made a note where I said A times I equals to A. Okay. Okay, sorry, I wasn't sharing my screen, but here it is. So A times I equals to A. We made a note of this earlier. Now what happens if I make I the subject? Now since this is matrices, okay, it's not like you take A over to the other side, it gets divided, and now you have A upon A, which is equal to 1. But if you take A over to the other side, it actually becomes A inverse. Okay, and it will come after A. Why is that? In fact, just a minute. Let me write this down again. So earlier we saw that any matrix multiplied by the identity matrix gives you the same matrix itself. So A times I equals to A. Okay. Now A is a matrix, it's not a constant. Okay. So that's why you can't, if you have to make I the subject, you can't be like, I'll take A over to the other side divided by A, and the answer is going to be A upon A, which is equal to 1. Okay. Think of it as a function. You know how you have a trigonometric function? So let's say you have sine x, which is equal to 0.5. And if I ask you to make x the subject, so what are you going to do with sine? What happens if you take it across?
sine inverse.
Yep, it becomes sine inverse, and then you have sine inverse of 0.5. Okay. Now, if I have to make I the subject over here, I'm going to apply pretty much the same concept. Okay. That means when I take A over to the other side, it becomes A inverse. Okay. A inverse, which will then be multiplied by A. Now, the question is, where do we place the A inverse? Do we place it after A or do we place it before A? Well, before we made I the subject, since A is before I, so A inverse will also come before A. Now, does it make a difference? In this case, no, it makes no difference, because in both the cases, both the matrices, whether it's the matrix A or matrix or inverse of A, both of them are going to be 2 by 2 matrices, so you can multiply them in any order, you'll get away with it. Okay. The only time where the order of multiplication matters is when the order of the two matrices that you're multiplying happens to be different. Okay. If the order is the same, then it doesn't matter. But this tells us something really important. You know what this tells us? This tells us that any matrix multiplied by its inverse will give the identity matrix. Okay, and let's put this to the test. So here we have one matrix which is 5, 3, 6, and 4. Okay, 5, 3, 6, and 4. And let's multiply this matrix with its inverse, which you guys found. Okay, doesn't matter what form you take, whether you take this form or this one, doesn't really matter. Okay, let's see what happens when we multiply these two matrices together. Okay, so row into column, 5 into 2 is 10, plus 3 into minus 3, so that's minus 9. Okay, 5 into minus 3 upon 2 is going to be minus 15 upon 2 plus 3 into 5 upon 2, that's going to be plus 15 upon 2. Okay, now we move on to the next row. Okay, so 6 into 2 is 12 plus 4 into minus 3, so that's minus 12. Okay, now it's time for this row to be multiplied by this column. 6 into minus 3 upon 2, that's minus 18 upon 2 plus 4 into 5 upon 2, so that's going to be 20 upon 2. Now let's simplify this and see what we end up with. 20 plus minus 9 is 1. Minus 15 plus 15 upon 2 is going to be 0 upon 2, which is 0. 12 plus minus 12 is 0. Okay. Minus 18 plus 20 upon 2 is going to be 2 upon 2, which is equal to what? Which is equal to 1. So what did you observe? When we took a matrix and multiplied it by its inverse, what did we end up with? We ended up with the identity matrix. Okay, so remember this statement. Any matrix multiplied by its inverse will give the identity matrix. Okay, always. So if let's say there is a question where you're asked to find A into A inverse, so you don't have to do any working at all. Okay, the answer is identity matrix. That's it. And this is going to be a 1 mark question, so the examiner is not expecting you to do any working anyway. Okay, so basically just remember this rule. Okay, just remember this rule over here. I'll write it down.
I'll erase this.
Yeah. So if you have ax which is equal to b, then let's say you have to find out x, so x is going to be b into A inverse. Or let's say you have xa which is equal to b, and again if you have to, sorry, wait a minute, it's going to be A inverse into b. Okay,
Yes.
or over here if you have to find out x, here it's going to be b into A inverse. That's how it's going to be. Okay. Acha. So as far as concepts are concerned, that's it. Okay, but I will obviously make you guys do a few questions before you leave. So mostly I would like you guys to do multiplication. So here's a question which I would like you guys to solve. You have one matrix P and another matrix Q. You're supposed to multiply them. Okay, so looks like we have an answer. 1 and 8. Okay, let me check quickly. Yep, 1 and 8 it is. Good job, Iman.
Sir, is it in rows or a column?
So let me check. It's a row matrix. 1 row, 2 columns. See, you have 1 row which is being multiplied by 2 columns. Okay, so that means your answer. So whatever value that you end up with once 3 has been multiplied by minus 1 plus 4 into 1 plus minus 5 into 0. So 3 into 1 is minus 3 plus 4 plus 0. Okay. And now since you're multiplying the same row with the column next to it, so that's how you're going to write your result as well. You're going to write your result in the same row but in the next column. Okay, so 3 into 1 is 3. Let's write that down. Plus 0 plus minus 5. In fact, plus 5 hoga. So 1 minus 3 plus 4 is 1 and 3 plus 5 is 8. So here's your answer. Get it?
Yes, okay, I got the correct answer, but I was just want to confirm because I
Alright.
thought didn't think I did. Okay, thank you.
You're welcome. Okay, so now I'd like you guys to do this.
Write it down.
Alright. What's the answer?
Minus 2, minus 1, minus 1, minus 5.
Minus 2, minus 1, minus 1, minus 5 or plus 5?
Minus 5.
Nope, it's going to be plus 5 because it's 0 minus minus 5. So it's going to be plus 5. See how many marks this is? Even though बाकी 3 elements ठीक हैं, but sadly एक भी mark नहीं मिलता. Alright, let's have the answer.
1 upon 8 bracket 3, 1, minus 5, 1.
3, 1, 1 and minus 5.
Yes.
Okay, great. 1 upon 8, 3, 1, minus 5 and 1. ठीक है, that's correct. Good job. Okay, so we'll keep it till here only. Now I will share this worksheet with you guys. Okay, this contains all the paper 1 questions. Okay, you'll notice that most of them revolve around the same concept. Okay, here and there you'll find maybe a tricky question. Okay, and there are you'll find answers as well at the very end. Okay, so you don't have to go through yearly past papers to see what the answer is. Okay, and I will also share a worksheet which contains all the paper 2 questions. Okay, you won't find a major difference. Okay, I mean, just look at this question. Do you see anything different? Does this really look like a paper 2 question? No, it doesn't. Okay, but still it's in paper 2. So yeah, but in the case of word problems, yes, you will find some complex multiplications for which obviously you'll need a calculator. Okay, so practice them, do as many questions as you can, and that's it. We will inshallah connect tomorrow. We will keep a class tomorrow. Now I would prefer to keep a combined class where we can cover maybe kinematics is one topic which we can cover in one class. Okay, so yeah, I'll let you guys know by tonight inshallah. Okay, but for now let's stop here. I will see